Now in this part, as we have already learned what is P wave represented, QRS and T wave. But you might be having a question in your mind, why the P wave is positive deflection, R wave is positive deflection, and despite being the repolarization, why it is positive in case of ventricular repolarization? So we will be dissecting that funda now. Suppose this is your heart, okay, and here is your SA node and here is your AV node. Let me also use another marker. So when the electrical impulse are generated in the AV node, they will gradually propagate through the atrium, isn't it? So suppose, and let's say when you are putting an ECG, this is your negative electrode and you put a exploring electrode here and you draw pictorial representation of galvanometer here. So here it is at 0, this way it is positive deflection, this way it will be a negative deflection. So it's clear up to now, yes? So in case of atrial depolarization, what will happen is that the electrical impulses from the atrium, they are propagating throughout the atrium, isn't it? So when you draw a vector, the resultant vector will be in this direction. So this is your resultant vector. So it's clear up to now, yes? Suppose if I take one piece of atrium, suppose this is one piece of atrium, or for more understanding, let's make it slant, isn't it? So what will happen is that when there is stimulus, inside it will be gradually inside it will be positive. So what will happen is that the positive vector is moving towards the positive electrode, isn't it? Here this vector of depolarization, of atrial depolarization, it is moving towards the positive exploring electrode, isn't it? So the deflection will be positive. So in case of atrium, the deflection is here. So there will be gradual upstroke and downstroke. Till now it's clear, isn't it? Now when the electric impulse, they come to this AV node, as we have already discussed in previous videos, that conduction is delayed in case of AV node, and it is such a small magnitude changes that ECG or the galvanometer does not pick up the changes. So the PR segment, what we have discussed, this in this case, when the electrical impulse, suppose now the electrical impulse has reached to this AV node, at that time there won't be any deflection, so the galvanometer won't show any changes. So this no change is recorded as PR interval, PR segment. So up to now this is clear, I hope. Now gradually what it will happen is that from here comes bundle of His, it gets divided, and these are your Purkinje fibers, isn't it? So what it will happen is that when the impulse they come through the bundle of His and Purkinje fibers, certain septal branches can be found from the left bundle branch, and because of this the aureolar depolarization will be seen in this direction. So here when I draw the depolarization, what will happen? Gradually the depolarization will be in this direction. So the depolarization takes place in this direction in the septal region. So when we draw the resultant vector, the mass of the septum is less, so the resultant magnitude will be less and it is deviated towards the negative electrode. So you see the positive vector is moving towards the negative electrode, so the deflection will be what? It will be negative. So this is our isoelectric line. So here you can see the deflection is negative because the positive vector is facing towards the negative electrode. So till now it is clear, I hope. Gradually what will happen is that now eventually the electrical impulses, they propagate, isn't it? So they propagate throughout the ventricles, isn't it? So in this phase, in left ventricle there will be one vector, in right ventricle there will be another vector, and when you take the resultant vector, so when you take the resultant ventricular depolarization, it will be greater in magnitude because the resultant is greater and the muscle mass is also greater. And you see here the positive vector is moving towards the positive electrode, so this is your positive vector moving towards the positive electrode. So you can see here the R wave is the resultant ventricular depolarization. So till now it's clear, I hope. So you have understood also the R wave. And another thing, now eventually the depolarization propagates to the base of the ventricle, and in this apical region, when you see the depolarization, they are facing this direction. So here the magnitude will be lesser because in this region the muscle mass is less and they are moving towards negative. So positive vector moving towards negative, again here the QRS, yes, wave is this representation which is negative deflection. So till now it's clear, I hope. Now one thing you have to keep in mind is, or you might be having some question like, why P wave is dome shaped whereas QR has spikes? It is so because in case of atrium the propagation of the impulse is slow, so the deflection will be also slow. However, in case of ventricle, because of the presence of bundle of His and Purkinje fibers, because in Purkinje fiber they will have direct rapid transmission of the impulses, so the deflection will be also short, so it will be quick, so you will be finding spikes. So this is the basic funda. Now what is this ST segment? This ST segment is nothing but the ongoing representation of ventricular depolarization and gradually the ventricular contraction. So ST segment especially denotes the ventricular contraction. Now we have our T wave here. So T wave, again it is positive deflection. How it is positive? Now I will draw another heart. Here I will draw. Let me confirm first of all whether it will be clear in the, yes, it is clear. So initially depolarization has taken place overall. Now it's the time of ventricular repolarization. So the basic funda to note is that the ventricular repolarization takes place from the apical region. So from the apical region you have negative vector, so ventricular repolarization is taking place. You might be thinking, why is there negative vector? As we have already discussed, in case of depolarization it's the positive vector that is propagating, but in case of repolarization it is the negative vector. When it is repolarized, so this is the case of ventricular depolarization. Listen carefully, this is ventricular depolarization initially. After ventricular depolarization there is overall depolarization. During this overall depolarization there will be no deflection, so that ST segment is overall ventricular depolarization which has taken place fully. Now after ventricular depolarization there comes the times for ventricular repolarization. during ventricular repolarization, repolarization starts from this side. So the thing that you need to keep in mind is that the repolarization has taken place from this side and the negative vector they are propagating this way. However, to keep in mind, now if the repolarization vector, let me draw it with blue marker. Now this is the repolarization vector. Now if we draw the resultant, it will be facing this way, isn't it? This is the repolarization vector and this is the negative vector. So the negative vector is moving towards the negative. So in first video what we have discussed is that positive vector moving towards the positive vector will be positive deflection and negative vector moving towards the negative direction will also be positive. So the T wave, which is the repolarization, will be found to be have positive deflection in the ECG. So this is the basic funda of understanding. So let me revise again. So this is your P wave. What is P wave? P wave is nothing but the atrial depolarization. So when the atrial depolarizes, the resultant vector will be like this, and you see the positive vector moving towards the positive deflection, so positive electrode, so the deflection will be positive. So you have your positive. In case of AV node, the electrical activity is such weak that ECG can't pick up. So the PR segment is isoelectric line. And when there is septal depolarization, the vector moves in this direction, that is positive vector moving towards the negative electrode. So the deflection will be negative in case of septal depolarization. And when the resultant vector of the ventricle depolarization is taken in account, then the positive vector will be deflecting towards the will be moving towards the positive electrode. So the deflection will be positive in case of ventricular depolarization. And this S wave is basal portion which is little bit remaining to take place the ventricular depolarization, and this positive vector is moving towards the negative. So here the deflection is negative. And this ST segment is nothing but the representation of complete ST segment. ST segment is nothing but the representation of complete ventricular depolarization. So this is the phase. So everything is positive, so there will be no electrical changes. So galvanometer or the ECG does not pick up anything, so there will be no deflection. So ST segment will also be isoelectric line. And T wave is nothing but the repolarization of the ventricle, and repolarization means here the negative charges eventually they get inside the cell. So this negative charges direction they are moving this way, and the negative charges moving towards the negative electrode means again the deflection will be positive. So basic funda is positive charges moving towards the positive electrode will be positive deflection, negative charges moving towards the negative electrode will be positive direction, and P wave is nothing but the atrial depolarization. So positive vector moving towards the positive electrode, so the P wave is positive. In AV there will be no electrical changes found out, so the PR segment will be isoelectric line. Q is nothing but the septal depolarization, and here you can see the positive vector moving towards the negative electrode, so here the deflection is negative, and the resultant vector of the ventricular depolarization is moving towards the positive electrode, which is positive vector moving towards the positive electrode. So the R segment, R wave is also positive, and the magnitude of the ventricular mass is higher, so the magnitude of R wave also increases. And you can see because of the Purkinje fibers the electrical transmission is rapid, so you can see the spike wave. And S wave is nothing but the representation of the ventricular depolarization of this part, which you can see positive vector moving towards the negative electrode, so the deflection will be negative. And ST segment is nothing but the representation of full ventricular depolarization, so there will be no electrical activity, so ST segment will be isoelectric line. And T wave is but what it is the ventricular repolarization phase. So repolarization takes place from the apical portion of the heart, so the negative vector they are moving towards the negative electrode, so negative going towards the negative, it will be positive deflection. So this is the basic funda.